Hey guys, welcome to Unit 5, Lesson 11. My topic today is the least rational equations. For the do now, I want you to pause the video and try that on your own. The do now says, what is the least common denominator, which is also known as LCM very commonly, for the fractions below. Whenever you're adding and subtracting fractions, if the denominators are not same, you do find the LCM or the LCD. I'll write LCD also. Okay, so I'm going to rewrite these denominators on the side here. And it's just xy, not 2xy. So how do we figure it out? So look at the numbers. You do the numbers first. 2, 2, and 1. What is the greatest common number or multiple of these three? 2, 2, and 1. It is 2. So 2 will definitely be your LCM or LCD. 2. Now, whenever you look at variables, you should have one of each. So there's x and y, so x and y. So this is your LCD or LCM. Okay, so now a rational equation contains at least one rational expression. Means, what are rational expressions? Anything that can be written as a fraction. So any number, all the integers, 2 over 1, it is a rational expression. But anytime you have a rational expression like 4x over 2 or I won't say 4x over 2, 4x over 3, something like that, or x over 4 or 4 over x, all those are rational expressions. So that's a rational equation. You solve them just like you would solve if it's a linear equation. Isolate the x. If it's a quadratic, set it equal to 0 and factor and so on. So, but what's the first step to doing these? So I'm just going to quickly do an LCM question. If I had 1 over 2 plus 1 over 3, what do? I want to add them. Denominators are not same, so you find the LCM. What's the LCM of 2 and 3? If you don't know, if you can't think of it, just multiply them, which is 6, right? So what did you do? You would set up two fractions with 6, and then all you try to do is compare. 2 times what gave me 6? 3, so I'm going to multiply the numerator also by 3. 3 times 1 is 3. What did you multiply here by to get to 6? 2, so you're going to multiply the numerator also by 2, just to keep that expression balanced, right? So 1 times 2 is 2. Now, since your denominators are same, you write it once and add the numerators. 3 plus 2 is 5. So this is how you added or subtracted fractions, going back to your elementary schools. Now we're doing a little bit more, not a lot, to be honest. So it's the same idea. There are fractions I see. So the first thing I'm going to do is get rid of my denominator. How do I do that? I get rid of it by finding the LCM. So I'm going to find the LCM of this. So what's the LCM of 2, 4x, and 4? So I'm going to do the numbers. What's the LCM of 2, 4, and 4? I'm going to write it on the side. 4, right? Between x's, it's just going to be x. So 4x is your LCM. So now what do? I'm just going to erase this, and I'm going to actually rewrite this question. 1/2 with a little space in there for 9 over 4x equals 3 over 4x. So your LCM is 4x. Then you're going to take your LCM and multiply each of the term by your LCM. So it's going to be 4x, 4x. I should have used a different color. 4x. What it does is when you multiply, if it's an equation and you multiply across by the LCM, what happens? It does one good thing. Your denominators will be eliminated. You'll be left with no denominators. So now take this. Simplify it. What's 4x divided by 2? It's 2x times 1. What's 4x divided by 4x? It's minus 9, just 1, right? And this also cancels out, so this would be just equal to 3. Do you see how easy it gets? So all you need to do is multiply the whole equation by the LCM, and then you are good to go. So now it's a linear equation, so I'm going to add 9. So get 2x equals 9 plus 3 is 12, divide by 2, x is equal to 6. So that's how you do these questions. The first thing is to do is, again, I'm going to write that down. First is LCM. Second is to multiply each fraction. I multiplied each fraction by the LCM, and then I took the LCM and my denominator and simplified it. Your check should be that there is no fraction, no denominator left. If you still had a denominator, sorry about the bell, if you still had the denominator, means that you made a mistake somewhere. Okay, so let's fill in the steps. What was the first thing you did? Find, right? We find the LCD or LCM, the least common denominator. Then what did we do? Multiply each side of the equation by the LCD. I would say each term. Cross that out, please, and write term of the equation by the LCD, right? So then simplify. What did we simplify? The LCD and denominator. That's what you're simplifying, so that all your denominators are gone. And solve the resulting equation. Again, if it's in linear, you are going to solve by isolating, and if it's a quadratic, you're going to solve by factoring. And check. We didn't do that. I'm going to go back and do that. Check for extraneous root. What does that mean? Values that will create a value of 0 in the denominator. So that's what your extraneous roots are. So if I substitute back 6 in here or here, does it give me a 0 in the denominator? It does not. So this is good to go. Okay, so let's start with the next. Okay, I even got a little started. For example 1, it says solve algebraically for x. So again, how do I know this is a rational equation? Because I see some variables in the denominator, there are some fractions, so that's what it's a rational equation. So now what do? I can rewrite 2 over 1 as a fraction. Now the first thing I told you is to do what? Find the LCD. So I'm going to write all my denominators. It's x plus 1, 1, and 2x. Right? So I'm going to start with my numbers. When I say numbers means, I'm going to put this in parentheses because this is a binomial. Okay? So there's just 1 in front of it. So the LCM of 1, 1, and 2 is 2. I'm going to do one thing at a time. You start with numbers, then you go to your monomials, and if there are binomials, then you're going to go there too. So now my monomial, I just have x as my monomial. So it's going to be just x. And then I have just one binomial, so I'm going to copy that binomial also. Okay? So this is my LCM or LCD. So now what's my next step? I am going to multiply each term. I'm just going to rewrite it. 2x times x plus 1. I'm going to multiply each of these terms by my LCM, x plus 1. 2x times x plus 1. And what will happen is, the magic of LCM will happen is that my denominators will be gone, and then we have a equation that we've been working with, either a linear or a quadratic, maybe a cubic too at times, depending. So let's see what cancels. So here the x plus 1, now I'm going to work with just the the LCM and the denominator, so be very careful. And this cancels. Right here nothing cancels because it was just 1, and here the 2x and 2x cancel. So what am I left with? I'm going to rewrite it. I'm not going to multiply it. 2x from here, and then I'm left with another 2x equals, I'm left with what? I can multiply this. This would be 4x times x plus 1 minus 5. I'm going to bring the 5 in the front, x plus 1. Do you see all your denominators are gone? And it makes it so much easier. So now multiply it out. I get 4x squared equals 4x times x is 4x squared plus 4x minus 5x minus 5, right? So now what happens is, if I want to set it equal to 0 because it's a quadratic. So I'll subtract 4x squared on both sides. Whoa, my 4x squared is gone. That's even better. So it is a linear equation. So add them. It's negative x minus 5. I can move the 5 over or x over, doesn't matter. See, how do I look at it? Because I saw that x is negative. If I add x on both sides, it doesn't matter whether you move your x on 5. So it's just that if you'd moved your 5, you would have an extra step of dividing by -1. So x is equal to -5, and that's your answer. But check. If I substitute -5 in here, does it make my denominator 0? Nope. Here, no, it does not make my denominator 0. So we are good. So x equals -5 is a solution. Okay, this one is a little bit involved, but you try it. Pause the video and see if you can try it. So the first step to do is find the LCM, right? That's what I've been telling you. Before you find the LCM, you want to make sure that all of them are in factored form. All your denominators are in factored form. I can't really factor anything from here. A minus 6 I cannot. But how about this one? I can. This can be factored to what? AM method. So it'll be A minus 6 and A minus 2, right? Two numbers that add to -8 and multiply to 12. So now I have to find the LCM of this. A minus 2, comma, A minus 6, and then A minus 2 and A minus 6. I don't know if you've figured it out. Here, the coefficients are 1, so it really doesn't matter. 1 will be there. But other than that, it would be each of the binomials. So A minus 2 times A minus 6. So that is your LCM. So I'm going to multiply each term by my LCM, A minus 2 and A minus 6. And I'm going to change color. 1 over. And I'm going to write my denominator also in green. So that way, you know what, you can see it. Plus A minus 2, A minus 6. Oh, this was A, my bad. This was A. This would be 1 over A minus 6. And then it equals A minus 6 times A minus 2. And then it's 4 over. And when we factored it, I'm going to read the factored form, A minus 2. Now what will happen? Look here. Again, you're working with the LCM and your denominator. The A minus 2's cancel out. So what am I left with? I'm going to copy that at the same time. A times A minus 6. Now here, A minus 6 cancel out. What are you left with? Plus A minus 2. Right? I'm going to leave it in parentheses. Especially, it doesn't really matter because this was a plus. If it was a minus, then of course you want to leave it in parentheses because you'll end up distributing the negative. And then what happens here? They both cancel. A minus 6 cancels with A minus 6. A minus 2 cancels with A minus 2. So you're just left with 4. Isn't that awesome? That's the whole idea. There are multiple ways, other ways also you can find out of doing it, like solving one side and then doing it. But I figured getting rid of the LCM is the best. So distribute the A. What do you get? A squared minus 6A plus A minus 2 equals 4. It's a quadratic, so I'm going to move the 4 over and I'm going to simplify this. So it'll be A squared minus 5A subtract 4. What do I get? Minus 6 is equal to 0. So now, again, it's a quadratic. Factor it. Is there a GCF? No. So what is it? AC method. It is the AM method. I need two numbers that add to -5 and multiply to -6. So it's going to be A minus 6 and A plus 1 equal to 0. Set them equal to 0. Make your t-chart. A plus 1 equal to 0. I get A equals 6 and A equals -1. I'm not done. I have to check. I know they are involved questions, but once you get it, like going from here onwards, you've been doing it in the past. This is the only new steps that you're learning. So if I substitute in 6 into the first fraction, 6 minus 2 is 4, doesn't get a denominator 0. But here, what happens? If I substitute 6 in here, I get a denominator of 0. So what is it? a equals 6 is a reject. I cannot have that solution. So the only solution is a equals negative 1. Okay, so I want you to now try the other questions on your own. I'm just gonna kind of try put this over 1, so that'll help you. And if you have any questions, reach out to your teachers. They're all doable, nothing crazy about them. They are involved, so don't try to skip any steps, and good luck, guys.